Hey, welcome to Keycloak Hour of Code. And our latest episode is going to be about observability. And for that, we have a very, very full house of people joining me today, some dear friends and colleagues. So let's bring them all screen. So yeah, good. Here we are. So welcome to the screens. Let's arrange it a bit more nicer. So we have Martin here on the call today. We have Ryan. We have Michael. All colleagues from Red Hat. So yeah, what about introducing yourself, Martin? You want to give it a start?
Yeah, sure. So I'm Martin Bartosz, and I'm part of Keycloak Cloud Native team. Yeah, and I think that's it.
And then Ryan, you're next.
Hi everyone, I'm Ryan Emerson. I'm part of the Keycloak SRE team, and recently I've been focusing on improving upgrades and observability within Keycloak.
Last but not least, Michael. Or Michael.
Yeah. Hello everyone. So I'm Michal, and it's very similar to what Ryan said actually, because I'm from the SRE team as well, working on observability, no downtime upgrades, this kind of stuff, and I'm also Keycloak maintainer.
Yeah, and it seems like everyone of us has been at a KubeCon conference before. Some of us have been there twice. So yeah, and it's going to be interesting stuff, how to do things in Kubernetes, or not only Kubernetes, but observability, and get it all set up. And let's get started. Well, we have a chat, and this chat, please do ask questions in there. So we are streaming on YouTube today live. We are streaming live on LinkedIn. You can paste the questions in the chat, and we will probably have all the questions answered. At the end, we have like 15 minutes of presentation, or maybe 20 minutes. Let's see how long it takes us, and then we give it a go. And the first one presenting will be Martin, right? So these should be your slides, if I gather it correctly. Give it a go.
Yeah, sure. So welcome everyone again. Today in Keycloak Hour of Code, we will be talking about observability capabilities that are part of Keycloak 26.2 that might help you in your deployments. Observability in Keycloak represents the ability to check the current state, Keycloak state, based on the emitted telemetry, like data generated by Keycloak. As for production environments, it's really crucial to understand how Keycloak behaves, or if there's some issue or some performance degradation. And in this presentation or in this talk, we will see some part of it, how you can leverage it. The three main pillars of observability are logs, metrics, and traces. We will discuss them one by one, and at the end you will see how you can connect them together and use them in a more production-ready environments. We can start with logs. I don't think we need to describe it sometimes some in a high manner or so, but it is essential in a service monitoring as we basically record the activities made in system, right, like Keycloak. Especially in Keycloak logs, you can show logs in a console, or store them in files, or even send them to remote syslog server. Right now we have a JSON support for the data as have them in a structured way. Recently we added the support even for the Elastic Common Schema, which might be even useful in some situations. Also, one quick news, it's not part of 26.2 right now, it's gonna be part of 26.3, but it's asynchronous login support that we added as you can achieve more stuff with that as well. In the future, we are considering even integrating OpenTelemetry logs. But as it's Keycloak hour of code, I think we can move on to the more hands-on for the login. What you can expect, how to configure it as and something like that. So you can everybody knows the Keycloak site, right? And if you want to set your login or something, you need to go to the guides and search for configure login. We have this guide for all these advanced stuff, how to do it. As I've said, console file, syslog file and syslog are the main log handlers that you can use for the logs. You can do whatever you want, specifying levels for each handlers or even for categories. It's quite handy to do it. You have
Can
also
you zoom in a bit?
Yeah, sure.
Okay.
You can use even the different format. If you wanna use the asynchronous login, you need to go to the nightly version of our docs. As I've said, it's not released yet, but it's gonna be handy for deployment using the asynchronous login. If you need higher throughput and low latency for Keycloak, or you have a small worker thread pool, it might be beneficial for you to use the asynchronous login. It has some trade-offs, as some additional memory overhead can be there, or potentially even losing some log records, as it manages the log records in a separate thread. Yeah, you can check this guide, and you can achieve whatever you want with that. And I think that we can move to the second part, which is related to the metrics. So, Michael, the stage is yours.
Okay, thank you. Yeah, thanks, Alexander, for sharing my screen. So let's start. So Martin, can you mute yourself, please? Yeah, thanks. So let's start with metrics. So what metrics are? And so the very basic definition of metric can be that it's like some kind of quantitative measure of some that represents some state or behavior of the system. This is maybe not much telling sentence, but as an example, from Keycloak, it can be, let's say, we can count how many logins happened in the system, Keycloak, and then at each point, when you open the metrics endpoint, you can see how many logins were done by this Keycloak instance. So if you open the metrics endpoint of Keycloak, it looks something like that. It's basically a lot of metrics, with each metric having a name and then type, and then the value that it has, including some labels. Labels means there are some additional information. So as an example, you can see a metric called Keycloak credentials password hashing validations total. And in help, you can see that it's password validations and type is counter. So we have a few types of metrics. One is counter, which is whenever some event or some situation happens in your service, the counter is increased. Then there are others, like for example, there can be timer, which means that we are not only counting how many of these occurrences happened, but you are also counting the total time that it took for all these operations to happen. And then you can, on average, compute what was the average time that this operation happened. This example is for counter, and you can see that this is number of hashing validations in total. You can see some labels here, which is, for example, realm, or whether the outcome was valid or not, and what algorithm was used. and then the number that is the number of validations that happen, in this case 28,000. So these metrics, well, if you just open this page and you see this static number, it's not much telling, right? Because it's like, okay, there were 28,000 logins or password validations, but it could happen in last week or last month or whatever. So what you basically need is to visit this page regularly, repeatedly, and then remember this number every time you visit this page, and then associate it with timestamp. So for this, you can use metrics collectors. The well-known metric collector is called Prometheus, and this Prometheus is basically a database for these values. And then based on some queries, you can query each metric by name. So as an example, you can see in Grafana. So you have Grafana that is then displaying the metrics or displaying graphs based on the data from Prometheus. So you can see that I use this query, which is the name of the metric, and then I'm filtering on namespace that is called runner Keycloak. And I can see there are three different values, or three different values for this metric. Each of them is representing one Keycloak pod, which is Keycloak 0, Keycloak 1, and Keycloak 2. And I can see that there was a lot of password validation happening at this point, and then it was static for the rest of the day, basically. So you can see that between 9:55 until 10:15, 10:20, all of these password validations happened. So this is now part of Keycloak by default. This metric is available if you enable metrics, and all of this you can find on Keycloak webpage. So if you open Keycloak webpage and go to guides, you can see there are observability guides, and here in this section you can see all guides related to observability in general, and some of them are for metrics. So here in this guide you can see how to enable metrics. Then we have something called event metrics, which is for each Keycloak event you can enable. You can have a metric in your metric endpoint, and you can then count it. Look at it if you want. I won't go too deep into this because I want to show this thing, and it's service level indicators. So what you can use metrics for are, for definition, so-called service level indicators and objectives. So what this means, so service level indicator or service level objective is something that represents how Keycloak performs, basically. So based on the indicator, you can see if it goes bad, it means that Keycloak does not perform well. If it is good or above some level, Keycloak is performing well. And in this guide, we are specifying 3 service level indicators. As an example, you can see is latency. So you can define your service level as latency, how long or how many seconds it takes or milliseconds it takes for Keycloak to respond, and that's an indicator. And then there is an objective that you want 95% of all your authentication requests below 250 milliseconds. And then you can see that you need to use these metric for it. So if you can then display this in Grafana and monitor it regularly, let's say, and then, however, you will find out that Keycloak doesn't perform well. But okay, what's next, right? You need to find out what's wrong, and for that there is another guide, and it's troubleshooting using metrics, which contains some list of useful metrics with explanation what it means, each metric, and you can then see you can then see what's useful to check if your SLIs fail, and it will give you some more details about what's happening. So for example, about the garbage collection overhead, or you can see the CPU usage. So maybe you will find out that your CPU is not enough and you need to scale or add more CPUs. Or there are some database metrics. So you can see how many connections you have, how many of them are idle, how many are active or waiting for something. And the last guide I wanted to show you is that all of these can be now also displayed in Grafana, because we have some, where it is? Here. So we have some Grafana dashboards that are shared for you, and you can use them, install them in your Grafana, and you have all of these metrics that are visible in the troubleshooting guide already in the Grafana dashboard. So the Grafana dashboards are available at this Grafana dashboard repository, and here is some screenshot for how it looks like. So you can then see these responses below 250 milliseconds in this period of time that this dashboard is looking at was 99.88%. And all of the rest of the troubleshooting metrics are here. And yeah, that's pretty much it, what I wanted to show you. So get back to you, Martin, for traces.
Yeah, sure. Thank you. The last from the three pillars is traces or tracing. We use OpenTelemetry tracing as a standard for it right now, as we use in the OpenTelemetry collector for it, and the use case for it is that we can track all the requests come in for Keycloak and even their life cycle, say so like that, as we can see what is the path they need to do in Keycloak itself, like even as Michal showed the hashing passwords, right? It's quite time-consuming operation, or even accessing database. We have all these informations, what happened hierarchically in Keycloak, and we also we are able to check calls for the social providers or even LDAP servers, and if we are able to see all these traces, all these spans that are coming through the with some stuff, as the benefits for it might be performance bottlenecks, as we know how time-consuming was the operation in that specific point, right? We can even better understand the system behavior, even better diagnose and troubleshooting, and also real-time monitoring for that. There's also quite interesting section about tracing, and it is using a sampler. As it's usual situation, as you don't always need 100% of your traces. If you do, there are some problems, right? If you store all these traces, you should check your huge bill for the data storing and even the degraded performance. So right now, by default, we use ratio-based sampler, as we can only specify that we might need only 10% of all traces to have some pros and cons for using this. We can find more information in a Keycloak guide as well, as it's called root cause analysis with tracing. And you can see enabling tracing. It's very easy. You can just put the property tracing enabled to true, and everything is done automatically via the OpenTelemetry collector. You can start your development setup To see how it works, at least in a simple scenarios, we use Jaeger for this. As you can see, all in one image, as we have the Jaeger UI and even OpenTelemetry protocol. So I can show you some stuff around the tracing itself. I already started the tracing all-in-one container and even Keycloak. We can look at it as a Keycloak is already there working, and we can access the Jaeger where we should see all these traces generated by Keycloak. We specify service as a Keycloak, and we can check whatever we want. We can find some traces for Keycloak. What was that? We can filter them out, as we can sort that we want like the longest first, as we have some authentication made for Keycloak as user accessing Keycloak, right? We have the parent span, as you can see, and we can also see the sequence of the operations that were made during this request. We can see also some more details about that, as we have some special Keycloak tags for that, as we can see authentication session ID, client ID, realm name, and stuff like that. Even the logs associated with that, as there was the login event, right, with some additional parameters, as admin was trying to authenticate to the master realm, right? But sometimes there are some issues with the tracing. We will see more. We will see more at the end when Ryan showed us this. Show this. But we can see also the invalid authentication attempts, right? We can see there are some errors in that, and we can also see how much time it took to complete it, right? We can see that there's some error here, and it's related to the password credential provider is valid. So yeah, right now we see that that the password is not valid, and we have more information about the process itself. On the Jaeger, there's also quite nice feature as a trace graph, as you can see all these invocations. You can also manage to emphasize the time spent in a specific spans, right? In a specific places, as we can see the password hashing took majority of the time of the request processing. Approach we can achieve much more, even calling the remote services like the LDAP or the social providers. Yeah, so you can check if there's some performance bottleneck, or if something fails to you can see it everything here. Right now we have also internal SPI for the tracing, as you can even create your own custom spans for your Keycloak extension or so. Yeah, but we will see better examples in a more advanced stuff that Ryan will show us right now. Handing over to Ryan.
Thanks, Martin. Could you just mute your microphone? Yeah, great, cheers. Yeah, so thanks to both of them for the overview there. What I'll now do is, you should be able to see my screen, hopefully. I'll now kind of talk through how we integrate the tracing metrics and logs together in kind of a unified way.
You need to share your screen again, I believe.
Sorry, I had to rejoin the call and I forgot to do that. But it's my screen.
No, you're sharing.
Yep, we're good now. Okay, sorry about that. So yeah, so now we are bringing everything together in like a more production-like system. And what we want to do is show how we can combine traces, metrics, and logs in a unified way to help SRE teams and other developers, etc., identify and debug problems. So just for this demo here, the architecture we're using is kind of based upon de facto standard tools. We have a Kubernetes cluster, which is based upon a local Minikube instance I have running. Within that, we have a single Keycloak pod, which is communicating with a Postgres database. Then on the observability side of things, we're using Prometheus to scrape the metrics. We're pushing our tracing spans to Jaeger, and we're consuming our logs via Promtail, which is pushing them to a low-key store. Then the really nice thing is we're using Grafana to integrate all these observability elements and provide a single integration, a single pane of glass, if you will, to view this in action. So as we're saying, this is like a production-ready system. We're going to use an example service level objective here. And what we're going to say is we want 95% of all our authentication-related requests should be faster than 250 milliseconds. And we are saying within a 5-minute range. So please humor me here. In a real world deployment, you would probably say 30 days, like Mikhail showed in our documentation earlier. But for the purpose of a demo, a 5-minute range, it just works a lot better. So let's roll with that one for now, please. So I'm going to jump now to the Keycloak console window. We'll see the login screen, hopefully you're familiar with. We'll sign in. It refused me at first there. I don't know why. Luckily, it worked the second time. So within this Keycloak instance, we have 3 different realms. Within realm 0, the current one, we have 100 different users. And what's going on in the background is, if I quickly jump to my terminal, we have a Gatlin scenario from the Keycloak benchmarks, which is logging a user in and out every 1 second. So this is a lightly loaded system, but it should be providing enough load for you to see what I'm hoping to demo here. So I'll go back to my browser, and I'm now going to go to our Grafana troubleshooting dashboard. In this dashboard, we have lots of different panels, but the first one we call our SLO metrics. And there's a few things going on here, but we can see we've got the dashboard to set to show the last 5 minutes of what's going on. And within this, we have a visualization to show availability. We have one Keycloak pod, and it's been up the whole 5 minutes. We then have this second responses below 250 milliseconds, which currently is 100%. That's what I was expecting. So the demo is going well so far. And next up, we have error responses, which is 0%. So again, things are going as expected. So before I start showing you more of the dashboard, I'm just going to jump to my terminal, and I'm going to introduce a problem into the system. And hopefully we'll see that shortly. But while things are looking well, I'll just talk you through the rest of the dashboard. So within this troubleshooting dashboard, we have some common kind of metrics that you would typically use to identify problems. Keycloak is Java-based, so we have JVM metrics. We have average memory used, CPU usages, average garbage collection times, changes to garbage collection times over a period of time, that kind of thing. A lot of the usual suspects really here. Next up, we have some database metrics. So this is connection pool utilization, available connections, used connections, that kind of thing. This is a lightly loaded system, so it's saying 0% connection pool utilization. It really means 0 point something, but ignore that for now. But interestingly for this demo anyway is, as I say, we have users logging in now every second. So we have visualizations for the different HTTP requests that are going on with the server. And I'll draw your attention to 2 visualizations here. One is the requests per URI. So this graph shows that, can't really see very well here, but we basically have 2 URIs that are being hit more than a lot of the other ones. And if we look at the key of the visualization, we will see that we're hitting the authentication endpoint and it's getting a success. And we're also hitting the authenticate endpoint, which is resulting in a redirection, as we'd expect. Next up, we have the usual readiness and liveness probes, which are working as expected. So this graph's nice because at the moment we're getting nearly all successes, but when we do have problems, they will show up. So you can maybe see here we have one client error, and that could be cause for concern in some cases. So I'll just jump back, and the next visualization that I want to focus on is this requests with respect to processing time. This very much relates to our service level objective. Change the time period here to the last 5 minutes. Yep, whoops. So what we have in this visualization is we have all requests based upon the latency, the time taken, grouped into buckets so that we can quickly visualize all requests that occurred, in this case where I'm hovering here, between 44 and 50 milliseconds. Now, at the start of my ramble, I said that we would be showing how you bring metrics, traces, and logs together. What we're doing here, what I'm going to show you now, is what Grafana calls exemplars. And an exemplar is represented by this nice little purple square. And what we can see is this exemplar relates to the HTTP server request second metrics, and that metric relates to the authenticate endpoint. So, okay, that's not too interesting in its own, but if I now click this query with Jaeger button, what we will see is a visualization very similar to what Martin showed earlier, except instead of using the Jaeger UI, we're now embedding Jaeger within Grafana itself. So this visualization here, the graph looks very similar to what Martin showed. At the top, we have a kind of a timeline. The total request took 45 milliseconds. And as we break down this operation, we can see that we have individual spans. And from this, we can see that the authenticate form took 25 milliseconds, hashing took 23 milliseconds, that kind of thing. What's interesting here, though, is we have a bunch of calls to the database. And if I select this select statement, what we can see is that we have some metadata associated with the span. It's associated with a Postgres database call, the SQL statement used, that kind of thing. But really nicely, what we can do is we can click this logs for this span button, and we can actually find the logs that are specifically associated with this time period and with the trace and the metric itself. So in this example, there's a lot going on, but we can see there's 3 different log statements displayed, and we have the JSON login output here. So we can inspect and hopefully determine something from the logs. In this particular case, the log isn't that interesting. I just included some debug logs just so we could visualize this better and so you can see how it works. So if I just go back here, just a final span I will point out is that select statement took an order of microseconds. If I go down here, we have some transaction commits. These have taken 20 milliseconds total. So things seem quite good. We're well below our original SLO target of the request taking less than 250 milliseconds. But now what I'll do is I'll jump back to the troubleshooting dashboard, and hopefully we will see that things have started to go wrong. And we can see, if I go back to the SLO board, now 50% of our responses are below 250 milliseconds. And if I go down to the HTTP metrics again, our heat map here shows that actually nearly all of, well, a lot of our URI requests are now in this 800 millisecond bucket. So something's clearly not right with our system. So because we have exemplars enabled, what we can do is we've just seen how an exemplar works in a normal working scenario. What we can do is click on the exemplar, and I'll just scroll out here so I can actually get to the button. So if I click on the exemplar here and I go with the query with Jaeger button, you can see that this metric actually relates, this exemplar relates to the same metric that I was talking about earlier, which is associated with the authenticate endpoint. So if I click this query with Jaeger button, we have the exact same timeline as we had before. However, now the request is taking 738 milliseconds or 600 milliseconds. And what we can see if we start investigating the individual spans is that the authenticate form took slightly longer than before, 100 something milliseconds. The hashing took around about the same milliseconds, so that indicates, you know, things are probably fine there. However, now when we look at the select statement that we looked at closely earlier, we can see that the associated value is 100 milliseconds. And as we go down, we can see that actually all of the spans associated with database operations, commits in this case, are taking hundreds of milliseconds at one time. So without having to even look at logs, we can see from a nice high-level view that maybe the problem with our system is at the database layer and is associated with Keycloak to database communication. So hopefully you'll get an idea how this abstraction simplifies SRE developers' roles. They can detect problems earlier, and more importantly, when a problem is detected by alerting, etc., they can quickly narrow down the scope of the problem and know where to start looking for the issues. That was everything I wanted to show you today. If you're curious, the reason for the delay was I just added an arbitrary 100 millisecond delay using Chaos Mesh, and that's why we can see such uniformity on the spans here on the graph. Well, that's everything from me, Alex.
Yeah, great stuff. Thanks for sharing all that. And we now have lots of time for questions. We already have some questions in the chat, and I will now go through them. So let's start at the beginning. So what was the first question about it? Yeah, I should be prepared on this one. So there was one question about Olivier was asking a question. How do you declare a metric, and how can you maybe add some my own counters in here? Is that possible with Keycloak today? How would I do that? And maybe expanding on what counters we have today. Anyone want to take that question?
I can take that. I prepared a little bit of the source code.
Okay.
Since it's Keycloak hour of code. So will you bring my screen on? Yeah, okay.
It's a bit small, but maybe you want to zoom in.
Okay, I will. Think about it. Oh, so first of all, so for this, for metrics, we are using something called Micrometer, which is an open source project, and we are using it via Quarkus, or Quarkus supports it, and this micrometer is taking care for sharing these metrics. And so in the source code, it then looks like, yeah, is it better? So we have then something called meter provider, and then here you specify what metric you want to share. So we use counter, but the same way as there is counter, there are also these timers and other types of metrics. And you specify that you want some name. In this case, it's exactly the metric that I showed before, which is credential password hashing. Then you specify description, units you are using, and then use this global registry. And then when you want to use it, you then use this meter provider just like this. You say meter provider and increment. And this way, in your source code, you can use you can add your own metrics, and they will be available at a metric endpoint.
Okay. But what you're saying, like, would be for those people who want to write their own extensions, I believe. Those could like have their own metrics and their own extensions. I think for the current core of Keycloak, what we currently do today, we collect these event metrics, right? Whenever there's an event, we count them, and this is the events we deliver out of the box. So besides that, well, they are the events you get out of the box, but there's no way to configure additional metrics except for the event metrics that are there today, at least, and the password counter and the Quarkus metrics and the HTTP count and what. But there's not something like, let's define my own metric. We don't provide it today, unless you write an extension.
Yeah, true. So about the user event metrics that Alexander mentioned, you can enable them. There is a guide in the observability section called Monitoring User Activities with Event Metrics, and you can enable it with this option. You can then also pick what events you want to capture and what not.
Yeah, and you can split them down by realm and by client and by IDP if you want to. But then, yeah, we love to get your feedback if that's helpful or if other things are necessary. Good. And Syed asked a question about the Grafana dashboards. And yeah, you presented that as well, right? You presented the dashboards.
Yeah.
They're free to download, right, on the Git repository today.
Yes, it's also available in this guide, as I showed before, in the Grafana dashboard repository. And basically, Ryan showed more from these metrics or from these dashboards in his demo. So we don't need to go through it again.
Yeah.
I guess.
There was a question from Peter asking about what about error traces, if all of those are sampled or not. Well, the thing is, I might give first part of the answer, maybe somebody else wants to join in. So the thing is, tracing starts at the beginning of a request and at the end of the and you might know only at the middle of the request when an error occurs. So the sampling starts at the beginning, and you need to start to capture all the data during the request, and only at the end you know if and how many requests have been successful. So I'm not too much into OpenTelemetry, but maybe somebody else wants to join us on our call with a more OpenTelemetry metrics specialist. Eventually you could capture more of your traces and then keep those traces which have errors on them for a longer time. Maybe that's possible. But that's probably another person you have to ask about and how to do that. Anybody else wants to add on that? Something that I missed? Talking about traces, there was one more thing, and please keep asking questions. So we still have 15 minutes, and we want to fill that 15 minutes with more great answers to even greater questions. When you look at these traces, we also have a lot of context information in them. I'm not sure, Martin, if you can get up your screen again, or to show another trace. And for example, on each trace, there's information on what realm that trace was, on what user it was, on what client it was. So all this information is available as context information, as tags on a trace. And you could actually use that in the search UI of traces. But yeah, if you could show that in a screenshot, that would be nice. Otherwise, I might show it later, at least in the docs.
Yeah, sorry, I wasn't sharing. I think. Can you see my screen?
Yeah, now we can see it. Yeah.
Yeah, so there's the tags, right, for the tags, and if I'm not mistaken, you can filter it by it, right? Like realm name master. Is it like that? I'm not sure. Yeah, it should be like that. I have only one realm, right? right now, so you should be able to filter these traces based on our Keycloak tags, which are also part of the guide, I think. Yeah, so you can find them.
Yeah, I have them in the guide, and I think you can even filter by user session. So if you have a single user session and want to see what that user session has been done over a period of time, you can filter by that ID, depending it has been recorded, of course. Otherwise, you will not be able to see it. And what we didn't mention about traces yet, I think this trace ID will also appear in the logs. Well, that's probably one of the reasons why the demo of Ryan worked in the end. Even if you choose to not record any of the traces, just enable tracing, it will add these correlation IDs to the logs, which can be a great help to people combing through the logs and see which requests belong together, which log lines belong to one request and all that bits. Yeah. So going for more questions. So there are not so many questions, so please keep asking. So otherwise we might need to end early. Rishi Jai was saying thanks for presenting all that from the Keycloak team. Yeah, and we're happy to do so. I hope we will have more of that again in the future. We have Keycloak Hour of Code. That's the meetup. Well, I usually post it on LinkedIn and also now and then write it as a blog. But I will post the link of the Keycloak Hour of Code meetup on Meetup. And if you subscribe to that event, you will get a notification if there are any upcoming conferences or talks or things online. Yeah, so that's a good place to stay in touch with us. Actually, on this Keycloak Hour of Code, we not only have people from the Keycloak team. In previous episodes, we had a lot of other people here. We had Nico here on the call. We had Sebastian here on the call. So if you have a story to share that's interesting to Keycloak users and has something to do with code and can fit into 1 hour, you're welcome to be here on stage and present it and get some feedback and questions from the community, which I think it's a great format of presenting things. Right.
And Alexander, if one of the viewers today had a specific topic in mind that they wanted to know more about, is there a way that they can request that? What would be the best way to do that?
Yeah, you probably find, well, you can go on the Meetup page and contact me as one of the organizers on Meetup on the platform. You probably see also my contact details on my GitHub forum, and good that you asked that. I will put that also here in the chat. So that's my GitHub profile with also contact details on it. Yeah, what else there is to know? Yeah. I don't know. Anybody else want to share some extended demo? We still have about 10 minutes time.
I have one thing I can share.
Yeah, please do.
So I have some real life example how we use these. I can share my screen. Okay.
Yeah, maybe zoom in a bit, but yeah.
Yeah, of course. Wrong.
Yeah,
window.
let's see. Maybe a bit. Well, yes, I know that you want to show all the tabs, but yeah, but then.
No, that's fine. So at some point, so we have our daily performance tests running, and at some point we found out, okay, our SLIs are not as we would like. So we have some, okay, from the beginning, this is a time of the whole performance test that we were running. It's like 10 minutes. And we found out, okay, from the beginning of the performance test, the SLIs or SLOs are okay. We have almost 100% below 250 milliseconds. But then later on, it's starting to drop, and it drops even to 20%, which means that something very bad is going on. Here is also that this is the response or output of our Getlink load runner. And we can see that mean response time of all requests was 112 milliseconds throughout the whole test. So we went through the dashboards and we found out, okay, there are some things going on. So the first thing was that there are these HTTP threads, and when you have HTTP thread waiting on something, it's visible in the dashboard as waiting. There is a graph for that. We can see that there are some spikes around that. So at some point, there were 45 waiting HTTP threads, which kind of corresponds to the time when the SLI dropped. And then you can also have a look at the database connection pool. So this graph shows the connection pool stats. How many connections how many database connections are used, how many are idle, and how many are waiting. And so on this graph, you can see that so down there is a number of used connections, and up are available connections, and you can see that they are approaching each other. So when you see that they are crossing each other, it's starting to behave badly, basically. And then this was running on Aurora database in AWS, so you can also have a look at the metrics or observability section in AWS, and you can see that CPU utilization was at 90%. So it seems that something is going on with the database. So what we tried is this was running on a database node with T4G, which means that it had, if I'm not mistaken, 2 CPU cores, and it seems that it was not enough. So then we tried the same experiment, the same performance test with it was large, and then this is X large, and X large had 4 CPUs instead of 2. And you can then see that the performance test was much better. The service level objectives were met, basically, so it never dropped below 99.6. And then there are no spikes in the HTTP threads about 10 or about 9, and the connection pool was okay as well. You don't see the graphs approaching each other, so it means it's okay. And then again, the CPU utilization was much lower, and the response times from Keycloak benchmark from Gatling mean response time was 50. So it's half of the previous one. And that's how we found out that in our performance tests, we are using wrong database or database with low amount of CPU cores.
Yeah. Thanks for sharing this real life example. Like, we're running these kind of tests every night, and then comparing the results from a day-to-day run. So yeah, that's how we then figure that out. There was another question in the chat in the meantime from Anis. Does Keycloak log events about failed and successful login and OTP attempts? Yes, they are logged. So there's an event, and you can choose where this event should appear. If Keycloak should write this event to a database, if Keycloak should write this event to the log, or if you choose to have this event just counted in the user event metrics that Michael just showed. So I'd say that's a yes from our side. I hope that answers the question. And there was another question from Andre. I hope I pronounced that name correctly. Did you try stacking the OpenTelemetry OTP with the OTel Java agent and OTel collector? Can we just add the IO micrometa registry as a dependency and configure the Java agent, and that's it? I might not get 100% of that question, but maybe Martin, do you have any news on what's next on OpenTelemetry and Quarkus for us?
To be honest, I haven't tried this setup, but from what I know, as we are quite tight to Quarkus, they created another project or extension. It should be like micrometer to OTL, OpenTelemetry bridge. So after that, we might be able to even export micrometer metrics and stuff to OpenTelemetry. So I think that will be the supported way in the future for Keycloak, but we need to find out how to properly include it. Yeah.
I think, well, about asking the OpenTelemetry Java agent. So yeah, we used it for a moment in time to do some early testing with OpenTelemetry. Well, but only up to the point where we were then adding OpenTelemetry tracing to using it from a Quarkus side and adding it to Keycloak. So if you say you use only, well, so my recommended way for a production environment would be use OpenTelemetry tracing as provided by Keycloak and use the Prometheus endpoint of Keycloak, Prometheus metrics endpoint. It is the fully supported thing. You could try to add the OTel Java agent, and then the OTel Java agent might be able to extract the metrics for you. But this instrumentation, last time I used it, it was slowing down things a bit on startup time, and we're not testing this for production environments. So yeah, it's a choice you have to make. I can't give you the ultimate advice here, but the supported way, I can only say, is metrics using the Prometheus endpoint and traces using the OpenTelemetry as built into Keycloak. And maybe we eventually move on to support also metrics with OpenTelemetry. But I can't tell when this might happen. To say it in a very vague way, I have to say, but yeah. Good. All right. So it seems we're wrapping up here. We have no more questions here. So a big thank you for the 3 volunteers who came up on stage together with me here today. Thank you, Martin. Thank you, Michael. Thank you, Ryan. I hope you enjoyed it as much as I did. And yeah, maybe see you next time. Thank you. Bye-bye.
Thank you. Bye.
Thank you very much, and thank you everybody for joining.
Yep. Thanks. Bye.
Bye.